zero rows. This is your matrix, if I can draw. So you have this, for example, the first row is 0. All elements are 0, right? Something like that. And the second row is not 0. For example, it has 1 over here, and then 0, and then 0, and then 0. The third row is also 0. All elements are 0. And the fourth row is also non-zero. You have 2, 1, 1, and 1. So you have 2 non-zero rows, the second and the fourth rows. And you have 2 zero rows, the first row and the third row. You should interchange the positional rows so that 0 rows become in the below of non-zeros. So, for example, you can do something like this. So the first row is 1, 0, 0, 0. It is non-zero. The second row is 1, 2, 1, 1. It is non-zero. And then you bring your 0 rows, right? 2 0 rows. Okay, is it clear now?
Yes, Doctor.
So the first matrix, this is not in the echelon form, but the second matrix is in echelon form. I mean, not complete in the echelon form, but it satisfies the first property of echelon form, right? Okay.
Excuse me, Doctor.
Yes.
If we get the echelon form, but the leading entry, it's not 1. It's, for example, 2, 3. It's non-zero, but maybe it's 2 or 3. Is that echelon form, or it's still not echelon form?
No, it is not echelon form. So you divide that row by the value of leading elements, right? For example, your leading element is something like 2, right? This is not in echelon form, but you can divide that row by 2, all elements of that row by 2. After this operation, it becomes in echelon form. Is it clear?
Clear, thank you.
Okay. So the next definition. The next definition is reduced echelon form. Reduced echelon form, more than the previous 3 properties, it should have 2 additional properties. The leading element is 1, and the leading elements, they are the only non-zero elements in the column. So let me tell you, so in the echelon form, non-zero rows are above 0 rows, right? You have first non-zero rows and then 0 rows. This is the first property, and the second property is that when you move from top to down, leading elements of non-zero rows moves at least 1 column toward right, something like that. These 2 properties are for echelon form. So if leading elements are non-zero but are true, they are in echelon form, but they are not in reduced echelon form, right? So for reduced echelon form, we need leading elements to be 1. This is one extra property, and the other extra property is that the elements below and above leading elements are 0. In echelon form, the elements below leading entries are 0. In reduced echelon form, elements below and above leading elements are 0, right? So you can you have a matrix. You have any arbitrary matrix. You can use row operations to convert this matrix into echelon form or reduced echelon form, right? We will see how to use row operations to generate reduced echelon form or echelon form from a given matrix. You know, the reduced echelon form of a matrix is unique. So a matrix may have many echelon forms, but it has a unique reduced echelon form. So please keep this in your mind. The reduced echelon form of a matrix is unique. So what the next definition is pivot position and pivot column. What is a pivot position? So you have a matrix like A. You convert this matrix into its echelon form like B. We will see an example of this. So B is in echelon form or reduced echelon form, right? Some of columns of B may have a leading entry, some others may not have a leading entry. Those columns in B that include a leading entry are called pivot columns, and their positions are called pivot positions. And those columns in B that do not include a leading entry are called non-pivot columns, right? So let me repeat this. We have a matrix A. We convert this matrix into its echelon form, like B. In B, some columns include a leading element and some columns don't. Those columns that include a leading entry are called pivot columns, and those columns that do not include a leading entry are called non-pivot columns. Those positions that are positional a leading entry are called pivot position, right? This is about B, who is in the echelon form. We also say exactly the same things about A. So a column of A is pivot column if and only if in B, in its echelon form, which is B, that column includes a leading entry. Otherwise, it is called a non-pivot column, right? Let's see an example of this matrix. So you have this matrix. Do you see this matrix?
Yes, doctor.
Yes, go ahead. Please.
Okay, great. We want to find its pivot columns, pivot positions, and non-pivot columns, right? We should first convert this into its echelon form using row operations that we learned in the previous session. So what is our algorithm? We choose the first non-zero column. So 0, it is a pivot column, and its top element is a pivot position, right? And it is non-zero. Okay, now after this interchange, it is non-zero. Okay.
Doctor, I have a question, please.
Yes.
When we interchange between these two rows, is it
Yes.
important to interchange with the value that is positive or not negative? My question is, if we matter all the element down the first entry, 0, all of it, it's a negative value. Can we interchange it with the first row or what?
Yes, you can. Instead of the first row, the last row, you can interchange the first row with the second row, with the third row. It doesn't matter if it is negative or positive, but it's better. It's better to, to interchange with positive. Your algorithm doesn't imply any restriction on this, right?
Okay, doctor. Okay, thank you.
So you can interchange with any non-zero value, right? So you can interchange the first row with any other row which has a non-zero value in the first column, because you want to have non-zero value in the top of first column. So you chose the first row, but you can do whatever you want. Okay. So after this row interchange, you will have this matrix. Now, this is the pivot position. The first column, this column, is a pivot column, and this position is pivot position. So pivot position is the position of leading entries. So the entries below leading entries should be 0. So these 3 should be 0. -1 should be 0. -2 should be 0, and 0 is 0. Okay. So how do you convert these elements into 0?
Using 3 options. That's the operation.
By adding row
Yes, by
1
adding.
Multiply
Yes,
and
go ahead. Go ahead.
multiplication and summation.
Exactly, yes. So, for example, you use row replacement. You replace the second row with the sum of second row and 1 times of first row, right? And you replace the third row with the sum of the third row and 2 times of the first row. So you want to have 1 in the first row and below it's 0, right? So you use row replacement to convert entries below a pivot position into 0. Over here, you see the resulting matrix after this row replacements. right? Is it clear?
Please, Doctor, repeat that. The second, yes? Yes, second step.
So the second step is that
Yes.
you
When
now
we change the rule,
so the thing is that this is your pivot position, this
yeah,
one on the top, and you want to build a echelon form, right? In echelon form, pivot position is the position of leading entries, and the entries below leading entries should be 0. So this should be 0, and this should be also 0. This is already 0, the third one, right?
yeah, how can I make it 0?
So you use row replacement. As your friend said, we solved an example of this in the previous session. So you replace. Unfortunately, it's not easy to write here, but you replace this row, the second row, by the sum of second row and 1 times of first row. So you do it, you replace the second row by the sum of second row and 1 times of first row. What would be the result? What would be the resulting row? You sum the second row with the 1 times of first row.
Yeah, like -2, -3, 0, 3, -1.
I don't see.
It will be 0, 2,
Yeah.
4,
Yes.
-6, -6.
Yes, exactly. And the first entry is 0, right? So you make the entry below 1, 0, right?
Yes, correct.
Okay. So you use row replacement in this way. And also you do a row replacement for the third row. You replace the third row with the sum of the third row and 2 times of first row. So you sum third row with 2 times of first row. What would be the result? You sum up the third row with 2 times of first row.
0, 0, 0, -5 and 0.
No? Yes, first 0, then -3 plus 2 times of 4.
It will
It will
be
be
0.
it will
0,
be
5, 10, -15,
Yes, exactly.
-15.
Exactly, yes, yes. And in this way, this matrix will be created. The matrix in the next slide, something like this. Right? So the first column is a pivot column, and its top element is pivot position. So you have found your first pivot column. Okay? And you should go for the second pivot column. Right? Is it clear until now?
Yes, Doctor, yes.
Okay, great.
Doctor,
Continue, Doctor.
what we if we face the first row, it was not 1. Can we divide the first one or the first entry of the first row by the itself to get 1, to get the
Exactly.
value
Yes.
1?
Yes, exactly. Yes, we can do it. It makes things much simpler. Yes.
Okay, Doctor, thank you.
So now let's move to the second column. We already did our operations, applied our operations on the first column, and then we go to second column. So what we do? So we ignore or cover up the row for which we have found a pivot position. So we already found a pivot position in the first row, right? So we just ignore the first row. We just remove the first row from the matrix. What is the resulting matrix? Something like this, right? If you remove the first row from the matrix. This is how your algorithm works. So the row for which you have found the leading entry, you ignore it, you remove it, right? Because its leading entry is already found. So you will have a sub matrix like this, like I have circulated here, right? So in this new matrix, you skip over 0 columns. So the first column is like this, it is 0. You skip it. The second column is something like this. It is 0 or non-zero.
It is non-zero.
It is non-zero, right? This one is non-zero. Do you see the movement of my mouse?
Yes.
Oh, great. So it's very good. So this is non-zero. So you call it a pivot column. So in this way, your second pivot column is found. This is your second pivot column. The second column of the matrix is your second pivot column, right? So the element in its top, which is 2, is called pivot position. So this 2 is pivot position, and the elements below this pivot position should be converted into 0. You should convert this. You should convert this 5 into 0 and this minus 3 into 0. How do you do this? How do you convert 5 to 0?
Adding minus 5 by 2.
Yes.
Doctor,
Yes.
adding minus 5 by 2.
Yes.
Sum with the column 2. Auto.
To row 2.
First, you can divide this row by 2 to make things simpler, right? 0, 2, 4, minus 6, minus 6. This row, you can divide it by 2, so that this 2 in the top becomes 1, right? Row scaling.
Right, Victor. Right.
Then, but in this slide, it hasn't done this. So you have this row as it is. But whatever. You use row replacement. You replace row 5 with the sum of row 5 and minus 2.5 times of row this row. And you replace this row with the sum of this row and 1/2 times of this row, right? In this way, 5 becomes 0, minus 3 becomes 0. And you enter into this matrix. You will have this matrix, right? Is it clear for you? You will have this matrix after these operations.
Doctor, why
Please, Doctor, can you
you...
make this one?
Doctor?
Yes?
Sorry. And the third row, why you don't making leading entry?
You can use it. I mean, yes, you of course you
Zero.
can. You can convert leading entry into 1. It's much simpler. It becomes your calculations much simpler. I mean, this slide hasn't done this. It's not obligation, right? It's not a must, but it makes things much simpler. It's better you do it in exam. You do it always, right? This slide hasn't done this because it wants to show that it is not an obligation. It's not a must, right?
Right, doctor.
But it's better. It's recommended. I recommend you do it.
Doctor, please, can you go back to the array above?
The previous slide? Yes.
Yes, doctor. The second row, it's divisible by the 2, right?
Yes.
So if we divide it by the 2, we will get 1, 2, minus 3, minus 3.
0,
So we will
1,
get
1 minus 3 minus 3. Yes.
so then we can do the operation by multiply after dividing the second row by 2. We will add it to the second row, but first time we will multiply it by the minus 5 and add it to the second row, and we will replace the result to the second row.
Yes.
It's possible, right?
Yes, it's possible. It's simpler and also simpler.
So I see it's also simpler than
Yes.
we divided minus 5 over 2.
Exactly. Yes. So I recommend you do it. You always divide this element in the leading entry by its value, so that you always have 1 in leading entries.
Okay, doctor, thank you.
So after these operations, you will have this matrix, right? This matrix over here. So in this matrix, okay, in this matrix, you continue. You have found the pivot position in the first row and also in the second row. So you just ignore or remove these 2 rows. These are rows for which you have found the pivot position. And you consider the rest of the matrix. You jump over 0 columns. The first 3 columns are 0. And you reach to the first non-zero column, which is this one. Right? Do you agree? This is your algorithm, how your
Yes.
algorithm. So you call this column another pivot column. So this is another pivot column.
So do we need to change now and make an interchange?
So let me go step by step. Let me go by step by step. So this is the pivot column. The element in the top of this pivot column should be non-zero. This is 0 now. So what you do, you interchange the third and the fourth rows so that you get a non-zero value in the pivot position of this pivot column, right? So over here, you do a row interchange and you get this matrix. So after this row interchange, what should you do is that you make the value below pivot position 0. It is already 0, so you don't need to do anything, right? So you are lucky, and for this pivot position, you don't need to do anything, right? For this pivot position, you don't need to do anything. Okay, great. Your next pivot position, your third pivot position was found. Now you ignore or cover the first 3 rows. for which you have already found a leading element or pivot position. You ignore this two. And the last row is the only remaining row. So you jump over its non-zero columns. Sorry, you jump over its zero columns to get to the non-zero column. But this doesn't have any non-zero column. You just jump over all columns and that's it. Then finish, you are done. You don't have any other non-zero column to call it a pivot column. So you don't have any other pivot column. So your pivot columns are those that are already found. So the first column, the second column, right? This is the first column. This is the second column. And this is the fourth column. These three are pivot columns. And what are pivot positions? This one, pivot position, and pivot position. These three positions are pivot positions, and these three columns are the first, the second, and the fourth columns are pivot columns, right? Because your algorithm found them as pivot columns. So what is the form of this matrix? Is it echelon? Is it reduced echelon? What is this?
Supposed to be, it's not echelon. It's still not echelon.
It is not
Doctor,
echelon?
is Echelon 4
Yeah,
in
you
1,
said before.
2 and 4?
You said before a couple minutes. You said echelon form. The leading entry must be 1.
No, it's for reduced echelon. For reduced echelon, leading entries should be 1, but for echelon, you don't need to have this property. For reduced echelon, so if I said it, I correct it. For reduced echelon, leading entries should be 1, but for echelon, you don't need this property. For echelon, you just need to have two properties. First, 0 rows are below non-zero rows. Second, when you move from top to down, the leading entries are shifted or moved at least one column toward right. So are these two properties, do these two properties hold here?
It is not hold, Doctor, because the third column, it is not echelon, it is 0.
No, it is echelon because, you know, this is the first row. And this is the leading entry of this row. And then you come to the second row. This is the leading entry. And then you come to the third row. This -5 is the leading entry. It is shifted at least once, not exactly once. It is shifted, in this case, 2 columns toward right side. So it's not a problem.
So now you mean you meant the first node, the echelon form, it doesn't matter if it's the leading entry, it's 1 or not. Maybe 1, maybe 2, but it's supposed to be not 0. And now you mentioned that we are following just the pivot positions and the leading. We don't care about the others.
We don't care about what, sorry?
Now, if we want to decide this is echelon form or not, so we have just to follow the pivot positions.
Pivot
Right.
positions are the positions of leading entries. So we should follow to check leading entries. Exactly.
Yeah.
We should, yes, continue.
Yeah, thank you. I have also a question. Now, if the -6 now, this one, it's over -5. It's if it's 0. If
Yes.
it is 0, okay, or there is an issue in there.
If it is 0, then what? I didn't get you.
My
You-
friend asked if it is the value of -6 above the 5. If we get 0 instead of -6, is it
Yes,
the array? It will also represent the echelon form.
exactly. Yes.
Yeah, because you know, doctor, excuse me, Mr. Saif, because the past step you made, you said you just record or you just marked the 0 above the pivot position. You said because of that 0, then we have to make an interchange or replacement. Sorry.
No. Then we are in the second row, right? So
Could you
we are
back
in
to the previous one, previous step?
yes, this one or this one? This one, I think. So in this case, we already have found a leading entry or pivot position in the first row. So we should ignore the
This
first row.
the step that's sorry, doctor. The step that the third row it's 0. All of the third row it's 0.
The third row or the second row, you mean?
The third one.
Okay, the third row is 0, so it's 0. So what's the problem? So over
No,
here,
just could you
yes,
go ahead? Just
so the
move
third row
on.
is 0. So we have found a pivot position in the first row. We ignore it. We delete the first row. So we now consider the rest of the matrix consisting of the second, third, and fourth rows. So the first column of this matrix, this is this submatrix, is 0. We
Doctor,
jump.
page 10, page 10,
Sorry,
page 10. صفحية
page.
ده. No.
You mean the next slide?
بالي.
Okay.
Yes, here you can see here you marked the 0 above the -5. So if
We did row interchange, right?
so we just concern about this 0, or we have to concern about whole row.
All row, because
Oh,
this row
thank
is 0, and as the first property of echelon form, non-zero rows should be above 0 rows. Right? The first property of echelon form says that non-zero rows should be above 0 rows. 0 rows should be in the bottom of the matrix. Right? So
Got your point.
if the third row, which is a 0 row, has at least one non-zero element, so this is how our algorithm works, right? So we already decided that what are the pivot positions of the first two rows. We ignore them, right? So we consider the rest of the matrix, which consists of these two rows, the third row and the fourth row. So we apply our algorithm. Our algorithm jumps over 0 columns. The first column is 0, the second column is 0, the third column is 0, and then we arrive to 0 minus 5, which is a non-zero column. We call it a pivot column, and its top element a pivot position, right? So this is a pivot position. But pivot position should include a non-zero value. So we should do a row interchange. That's the reason why we change the place of or the position of these two rows, right? This is how or why our algorithm interchange these two rows. But based on the definition of echelon form, in the echelon form, non-zero row should be above the zero row. So we interchange these two. We should interchange these. So our algorithm interchanges these two rows, row 3 with row 4, because the value in the pivot position should be non-zero. Right? Is it clear now?
Clear, thank you.
Doctor, please, one question.
Yes.
Can we see the result of this matrix?
I don't
Not
have your
not
voice. Sorry. Can you repeat? I don't have your voice clearly.
previous day.
Previous slide.
Ben. Yes, yes.
Yes, this one you mean?
Can you say, doctor, this matrix result is not reduced, but echelon form are not consistent.
I don't get your voice. Sorry, I don't
لا
understand.
سكتي بابا بدي احكي.
استاذ مصطفى علي صوتك ما قاعد يسمعك زين.
الله عليك دكتور. Hello, doctor.
Yes, yes, I don't understand what you mean. I don't have your voice very clearly.
Can we see on this result of matrix?
أستاذ مصطفى.
نعم. Hello.
Sorry.
Hello.
Hello, yes.
Thank you, doctor. Can we say this date or result of matrix it's not reduced and but echelon form?
Not reduce and what? Sorry, I don't get your question.
Not reduced and but echelon form.
Can someone say?
استاذ مصطفى احكي سؤالك بالعربي خلينا نترجم لك إياه.
Doctor, he's meant what he's
Yes,
meant.
yes.
The result for this matrix now until now, can
Yes.
we say this is echelon form, but it isn't radius form? So that's
Until
correct.
now, until the third slide, right? You mean, or
Yeah,
until
yeah.
the
Until the result,
last?
the last one. Here.
Yes, this is exactly. Your point is correct. So this one. The
Yes.
matrix in this slide, it is in echelon form, but it is not in reduced
Right.
echelon form. It is in echelon form because it satisfies two properties of echelon form. Zero rows are above, non-zero rows are above zero rows, and also when we go from top to down, pivot positions shift at least one column to our right side. So this is in echelon form, yes, but not in reduced echelon form.
Thank you, doctor. Thank you.
Okay, so in this matrix, in the matrix of this slide, what are the pivot columns? The first column, the second column, and the fourth column. They are pivot columns. So I'm asking you about pivot columns of the original matrix. This is the original matrix. What are the pivot columns of the original matrix?
First and second and the third.
And fourth.
And the fourth. Sorry.
Yes, exactly. So you convert the matrix into echelon form and find the pivot position, pivot columns, and then take the number or index of those columns, come back to the original matrix, and call columns with those numbers as pivot columns, right? So in the echelon form, you had 1, 2, and 4 as the number of pivot columns. You get back to this matrix and call column number 1, column number 2, and column number 4 as the pivot columns, right? So in order to find pivot columns, you should first find echelon form. In echelon form, pivot columns are clear, are obvious. You take columns with those numbers, get back to the original matrix, and call columns with the same numbers as pivot columns, right? So this is the original matrix. You take the same numbers, number 1, number 2, and number 4. Columns with these the same numbers as pivot columns. And also you take position or number of pivot positions and call them pivot position of the original matrix, right? This one, and this one. These are called pivot positions of the original matrix. So pivot columns of the original matrix and echelon matrix, they are different, but they have the same number, right? The same number. For example, the pivot column in the first pivot column in the original matrix is something like this: 0, -1, -2, -1. But the first pivot column in the echelon form is something like this: 1, 0, 0, 0. These two are different columns, but they have the same number, right? It is the first column over here, and it is also the first column over here, right? Is it clear? Is it clear?
Doctor, we didn't get what you mean, please. Because we see different value in the same column.
Exactly.
The original and the echelon form.
Yes, exactly. So what I want to say that if you want to find pivot columns of a matrix, you can't find it without computing echelon form. You must first compute echelon form, right? It's the echelon form, this matrix. And this matrix is original matrix, right? So in the echelon matrix, you see the pivot columns: the first column, the second column, and the fourth column. Columns with these numbers are pivot columns. So if you want to find pivot columns of the original matrix, you bring those numbers, not the columns themselves, but numbers: 1, 2, 4. And in the original matrix A, columns with these numbers are called pivot columns. So in the original matrix, which is A, column number 1, column number 2, and column number 4, these are pivot columns. The value of pivot columns in the original matrix and in the echelon reduced in the echelon form are different, right? The first column over here is 1, 0, 0, 0. Over here is 0, -1, -2, and 1. The values are different. But the number, the index of columns, pivot columns are the same. Over here, number 1, number 2, and number 4 are pivot columns. Also over here, number 1, number 2, and number 4 are pivot columns. This is what I want to say.
So,
So-
doctor, what's the reason to make this compare between this one and the original one?
This is how we define. This is our definition. Because it has later application. This definition has applications. So my point here is that you don't bring the columns themselves from echelon to original matrix. You take numbers, right? And you bring those numbers to the original matrix, and columns in the original matrix with those numbers are pivot columns of the original matrix.
So, doctor, what you mean that the original, we can find the pivot column from the original matrix after we change it to the echelon form, right?
Yes. But when you change to the echelon form, you find columns, but you don't bring the columns themselves. You bring the number of columns, the index of the columns.
Yes, doctor.
And
Only the
you-
index to discover what is the pivot column from the original matrix.
Exactly, yes. To discover what are pivot columns of the original matrix, you don't take the columns from the echelon form. You take column numbers, column indices from echelon form. Like 1, 2, 4, column number 1, column number 2, and column number 4 from the echelon form, and then you come to the original column number 1, column number 2, and column number 4. This forms the pivot columns of the original matrix. This is how we define, this is our definition of pivot column. And is this clear to you? Okay, let's go for the next example. It may make things more clear. So you have an original matrix like this, and you want to find its echelon form and reduced echelon form. So how the algorithm works? You start from the first column from left side. Is this 0 or non-zero?
Let's start with the
Not
leftmost
non-zero.
0. No 0.
It is non-zero.
pivot.
So you consider it as a
Can't have changed the
first pivot column.
pivot. So it is a pivot column. So its
Yes,
top
because-
element should be non-zero, but it is 0. What do
Yes.
you do?
By other rule.
Interchange the third row with the one row.
Yes.
Replace row 1 by 2
Excuse me,
or
doctor.
3.
Excuse me. Now, your point.
Sorry,
If
what?
the first column, if it's all zeros, if the first column, if it's all zeros, so that's mean we'll start from the second one, right?
Exactly.
But the first
You
one
jump.
will be yeah. So
You
the
jump
first
over
column
it
will
and
start from the second one.
Yes, exactly. You jump over 0 columns, and yes, you start from the second one, for example.
Thank you, Doctor.
Okay. So this is non-zero, and its top element should be pivot position, but pivot position should be non-zero, but this is 0. So you do a kind of row interchange. You change the position of first row with some other row. In this example, the slide has decided to interchange the first row with the third row. So you will have this matrix after interchanging the position of first and third rows. You could do this with the second row, right? It's up to you. So you have found the first pivot column and its pivot position. The entries below pivot position should be 0. So you make them 0. So you replace the second row with the sum of the second row and minus 1 times of the first row. Right? You do this row replacement, and then this matrix is computed, is obtained. So exactly follow our algorithm. For the first row, you already found a pivot position. So you ignore it or you delete it, and you consider the rest of the matrix. So this is the rest of the matrix. So in the rest of this matrix, you jump over the 0 columns. The first column is 0. You jump over it, and this column, the second column, is non-zero. You consider it as a pivot column, and its top element, this one, as a pivot position. All right, something like this. This is pivot position, and the whole column is pivot column. So you should make the entry below pivot position 0. You should convert this 3 into 0. How? By row replacement. You replacement the third row by the sum of third row and minus 3 over 2 of the second row. And then this obtains, this matrix obtains. So now in this matrix, you ignore the first and second row, because in the first and second row, you have found pivot positions. And just the third row of the matrix remains. In the third row, you jump over 0 rows. And the first non-zero row is this row. It is pivot, the first non-zero column. So in the third row, you jump over 0 columns. And the first non-zero column, which is this one, it is called pivot column. And its top element, which is itself, is called pivot position. In the next step, you need to make entries below this pivot position 0, but there is no such entry. So you stop here. So this is your pivot position. Sorry, this is your, last pivot position, and this matrix is your echelon form. This is your echelon form. The first, the second, and the fifth columns are pivot columns. This one is a pivot column, this one is a pivot column, and this one is a pivot column. The rest are non-pivot columns. This matrix is in echelon form, right? In order to convert this into reduced echelon form. What do? You start from the last pivot position. So this is the last pivot position. First, you make its value 1. It is already 1 because the leading entries should be 1. Second, you make the values about it 0. This 2 should be 0 and this 6 should be 0. How do you do this? By row replacement. You replace this row by the sum of this row and minus 2 times of the third row. And also you replace this row by the sum of this row and minus 6 times of the third row. After this, you will have this matrix. And this is your last pivot position. The next pivot position is this one, right? First, the entry in this pivot position should be 1. So you divide the whole this row by 2. This matrix is obtained. And in this matrix, you should make this value, the value above pivot position 0. How do you do this? By row replacement, by replacing the first row by the sum of first row and 9 times of the second row. So this is obtained, this matrix until now. So you go to the next pivot position, which is this one. You first should make its value 1. You divide the first row by 3. So this matrix is obtained. There is no entry about this pivot position. So you don't try to make those entries 0, and that's it. You stop here, and this matrix is called your reduced echelon form. Right? In this way, you find the reduced echelon form of a matrix. Is it clear?
Yes, thank you, Doctor. Until now, it's okay.
Okay.
Doctor,
Yes.
from this matrix, we inform that to get the reduced echelon form of this matrix, we only care about the pivot column, right?
Yes, pivot columns, pivot positions, yes.
Okay, Doctor. Thank you so much.
Okay, our time is done, is finished. So if you don't have any other question, we can stop here and continue the rest of discussion in the next session tomorrow.
Okay, thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Doctor, tomorrow also
Thank you,
online.
Doctor. Thank you so much.
Thank you, Doctor. Thank you.
Yes,
Thank you, Doctor.
tomorrow we will have an online meeting, online session like today in this link.
At the same link or new link?
The same link, yes. All online sessions.
Doctor, can you please send the slide to us?
Yes, I will send.